Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to have something very special and hopefully you enjoy it. Something a little different. I know some of you are tired of hearing from me every day and every week, and so I have asked a special friend of mine and a special friend of some of yours to come in and teach this class today. So we're going to have a guest professor today. And we are going to be learning how to do what's called synthetic division. We learned how to do polynomial division a few lessons ago, actually all the way back in chapter 1, I think, a few weeks ago. And now we're going to learn another way to do division in algebra. It's called synthetic. And so I have asked Miss Carli if she will teach for me today. So I hope you enjoy.
Miss Carli here. And for the last 3 years, I've been teaching at a high school in a small town called Kyle, Texas. And guess what I've been teaching? Algebra 2. And Mr. Steve and Ms. Julie and I have kept in contact. So when he messaged me and said, hey, do you want to be a guest teacher? I was like, heck yeah, let's do it. Let's talk about synthetic division. So I have a worksheet that I'm going to share with you from my iPad so that I can draw on it. Synthetic division is fantastic. You're going to love it. Nobody likes to do long division. It takes forever. And synthetic division is a quick shortcut. So if I have this polynomial right here, 3x squared plus 7x plus 2, and I think that x plus 2 is a factor, so if we were factoring, you would say, okay, x plus 2 times what gets me 3x squared plus 7x plus 2? Nobody likes to factor either. Synthetic division is even faster than that. So what you do to set it up is you have to check two things, first of all. In your dividend, this is your dividend, you have to make sure that the exponents are in order from biggest to smallest. So my biggest exponent is a 2, then I have a 1, then I have my constant. Okay, so check, those are in order from biggest to smallest. Now, there's none missing. Like for instance, say this term wasn't here. That would be a problem. We'll do an example later. For now, we're good. What we're going to do is we're going to take each one of these coefficients. The coefficient is the number in front of the variable. And I'm just going to pull them out and put them in a line. This right here, my x plus 2, I'm going to set it equal to 0 and solve. So I got x equals negative 2. And that negative 2 is going to go in a box right here. I know it looks funny, right? Now you've got your synthetic division problem set up. Put yourself a horizontal line right there. Leave some space. Okay, so now the steps for synthetic division are: step 1, bring down this first coefficient. That's all you've got to do there. Step 2, let's change to green. I'm going to take this number and I'm going to multiply them together. Negative 2 times positive 3 is negative 6. Then I'm going to take these two numbers and I'm going to add them. 7 plus negative 6, that's the same thing as 7 minus 6, that's 1. Now you're just going to go back and forth, multiply, add, multiply, add, multiply, add, until you get to the end. So now I'm going to multiply negative 2 times positive 1. Negative 2 times positive 1 is negative 2. That goes here. And then I'm going to add. 2 plus negative 2 is 0. So these are my answers, or my quotient. Now I know two things about this. Because I got a nice big fat 0 right there, it means that x plus 2 up there was a factor of 3x squared plus 7x. It divided evenly. There was no remainder. Second of all, I know what the other factor was. So if I was looking at my original polynomial, I started with an x squared term. My biggest term was an x squared. So I'm going to take that and I'm going to take 1 away from it. So instead of an x squared, I'm going to have an x. And this is going to be my coefficient. 3x. Then just like you stepped down with your exponents, you had x squared and then x and then a constant, we're going to do the same thing. So we've got 3x. The next thing would be your constant. And right there, I have a +1. So this is your factor. Okay, let's try it again. Here's another example. 2x squared plus 7x minus 15. I'm going to take my coefficients. Notice that there's a -15 right there. That negative has to stay with the 15. I'm going to take this and set it equal to 0. That gives me a -5 in my box. Okay, step 1, bring down your first coefficient. Step 2, multiply. -5 times 2 is -10. Step 3, add. 7 plus -10 is -3. Back to multiply. -5 times -3 is +15. And when I add those together, I get 0. So if I divide 2x squared plus 7x minus 15 by this, I get this as my quotient. This is just like the last one. My biggest exponent was a 2, so I'm going to take 1 away from that. This is going to be a 2x, and this is my constant, minus 3. That's your quotient. Now, it's nice that it ends in a 0 on these ones, but that doesn't always happen. So here's a different example. Setting it up the same way. Check to make sure your exponents are in order from biggest to smallest. They are, and there's none missing. So I'm going to put my coefficients down there. Set this thing equal to 0 and solve. So I have a -1 in my box. Okay, bring down your first coefficient. Multiply. Add. Multiply. Add. So I didn't get a 0 there. So my answer, whoops, I lost my 1. My answer, since my starting coefficient was an x squared, I'm going to take 1 away from that. I've got 7x plus 10, but then I have this 15. So what I'm going to do with my 15 is just like in a long division problem, you put your remainder over whatever you were dividing by. In this problem where we were dividing by x plus 1. So this is your remainder. And this is your final answer. If you were checking to see if x plus 1 was a factor, the answer to that is no. For this one, x plus 1 is not a factor because we had a remainder. Let's do this one. Okay. Are those coefficients, those exponents in order from biggest to smallest? You've got to rearrange them. So my biggest exponent here is a x to the 4th. I'm going to put that one first. That takes care of that. Then I step down from x to the 4th to x cubed. That takes care of that. Then my x squared term can come next, and my x, and my constant. Okay, so I'm not missing any, and now they're in order. So now I can put my coefficients in. I've got -1, -2, 3, 4, -4. And set this, your divisor, equal to 0, and solve. That means in this box goes a -2. All right, let's do our synthetic division. Bring down. Multiply. -2 times -1 is +2. Add. Multiply. Add. Multiply. Add. Multiply. Add. Yay, we got a 0 at the end. So I know what my quotient is. My biggest exponent this time in my dividend was an x to the 4th. So I'm going to go 1 down from that. So this is -1 goes in front of an x cubed term. That's an ugly 3. Let's try again. How many x squareds do I have? I have 0 plus 3x minus 2. This is called the depressed polynomial. I'm not sure if Mr. Steve needs you to know that or not, but I'll throw it in there. It's a depressed polynomial because you've factored out, you've taken out this x plus 2. Now, we don't want to write it with the 0x squared in there, and we can clean it up a little bit. So pretend this isn't here. I would have negative x cubed plus 3x minus 2. And if you were to take this and multiply it by x plus 2 to check your answer, you better get back to this original thing that you started with. So it's a good way that you can check your work. Okay, I want to do one more. This one right here. I want to show you an example because this one, it's from greatest exponent to smallest exponent, but it's missing some, right? There's no x cubed or x squared or x term in there. So if I were going to write this out, x to the 4th, I need to put a placeholder in there. I have 0 x cubes, and I have 0 x squareds, and I have 0 x's. And then lastly, I have my constant. So you have to put those placeholders in there so that when you write out your coefficients, you get the right numbers in the right spots. Solve this thing, set it equal to 0. I get a negative 3 in my box. Let's go ahead and do our synthetic division. Bring down, multiply, add, multiply, add, multiply, add, multiply. I don't even know what 27 times 3 is. I'm going to use my calculator. 27 times 3 is 81, and they're both negative, so a negative times a negative gets me a positive, and 81 plus 9 is about 90. Okay, so this was not a 0, so this isn't a factor, but we do have our quotient, we have our answer. If you multiply x to the 4, or if you divide x to the 4th plus 9 by x plus 3, you get an answer. And since we started with the greatest exponent of 4, we're going to take one away. This becomes a 1x cubed minus 3x squared plus 9x minus 27. And then we've got that 90 to deal with. Remember, you put that on the top of your fraction, your remainder. And then this x plus 3, your divisor, is what goes in the denominator. You've got your answer. Excuse me. Okay, so last thing I wanted to show you is all the problems I did so far have your dividend and your divisor, but it doesn't have to be that way. Like this one right here, it's a fraction. This is my dividend, this is my divisor. So you can set it up the same way. I have x to the 6th, x to the 5th. Do I have an x to the 4th term? So I'm gonna put a 0. X cubed. Do I have an x squared? Do I have an x? I have a constant. So 6, 5, 4, 3, 2, 1, constant. I got them all. And this time you're going to set this thing equal to 0, and your negative 1 is going to go in the box. All right, go ahead and work through that problem. See if you can get a nice factor or just a quotient with a remainder. I hope you have enjoyed learning about synthetic division.
Wasn't it great to see Miss Carli again? I know some of you had her as a teacher. Maybe that's the first time that you got to know her there, and she's a great teacher. I appreciate her doing that for us, and hopefully you learned something today. And if you didn't, make sure to go back, watch it again, rewind it, and pay attention because there's some things in there that you really need to know that's going to help you with this binomial theorem that we've been talking about. Okay? All right. Hope you have a good rest of the day. We'll see you later. Bye-bye.